Hi everyone, in this video we are going to continue with our Chapter 2 labs. This is the lab on frequency distributions. So it looks something like this when you download it from my math lab. We're going to be using parking ticket data from Toronto, Canada. So at the top of the page here we see a random sample of 100 different parking infractions from December 2011. So mostly the top row other than one were $30 tickets. There's a $60 ticket, 40, a minimum of 15. Looks like maybe the highest ticket was $105. Now for this particular lab, we're going to be working with Excel and the TI-84. So I actually have my simulator loaded, and we'll clear that out real quick. And then I also am going to be using an Excel spreadsheet. You do not have to by hand copy the data set into a workbook. I already have a pre-made blank Excel sheet in my math lab. It's actually at the top of the Chapter 2 lab, so this one is 2.4, and the workbook that goes along with it is actually a couple links up here. So you'll want to download, again, either the PDF or the Word document to fill in and save, and then you'll also want to download the 2.4 workbook that goes along with it. So we'll be using Excel and the TI-84 to complete this lab. Okay. So the first thing, obviously, that you want to do is open that workbook, and number 1 asks us to find the sample mean of the data set. So I want to show you how to go about finding averages and standard deviation using Excel. The great thing about Excel is that we can program it to find these values just by referencing different cells in the workbook. So we're not actually going to be entering in any numbers in any of our formulas. We want to create equations that just reference values in different cells. So we'll go through this together. Hopefully this video helps us learn a little bit about Excel, a little more about the calculator as well. In cell C1, we're going to calculate our sample mean by typing the function average, and we want to start with an equal sign. So maybe I can zoom in here a little bit. I'll expand this. To type a formula, we want to start with the equal sign and then the word average. And we're going to open a set of parentheses. And in the parentheses, I'm going to type capital A, colon, capital A. And this means just average everything together that is in column A. And then we're going to hit enter. So 39.05 is the average that I'm going to write here. And you might want to go through and insert an equation to say that our sample average, which is again X bar, is equal to 39.05. And this is in terms of money, obviously, parking tickets, 39.05. That's our average parking ticket. Okay, the next thing we want to do in number 2 is find the sample standard deviation. So I'm going to come down into C2, and we're going to type the equal sign again to start our formula. And the code for standard deviation in Excel is STDEV. Oopsies. STDEV, standard deviation. And we're going to open a set of parentheses and say from A to A, all of column A, so A, colon A, close parentheses. And our standard deviation is 17.07, $17.07. Okay. Now, for sample values, again, we use X bar to talk about the sample mean. We use lowercase s to talk about sample standard deviation. And any given parking ticket amount will deviate on average from the mean by about, at most, $17.07. That's how we're going to interpret our sample standard deviation. Number 3 asks us to find the class width, assuming that we're going to use 7 classes. So I'm going to donate C3 as our number of class cell. So I will reference C3 in my formula for class width, because if I want to create a frequency distribution with a different number of classes, then I'm going to change the value in C3. Maybe I want 5 classes, maybe I want 10 classes, but I want a cell that designates the number of classes I want to use, and then I want to reference that cell in my class width cell. So again, C3, we're just going to type the value 7. In cell C4, we're going to type the following formula, equals round up, because remember, whenever we go through our class width formula, we take the range and we divide it by the number of classes to figure out how big each bin or each class width should be. If it is not evenly divisible, we're going to come up with a decimal, and obviously I don't want a decimal as my class width, so I always want to round up that value, whatever it happens to be. So equals round up, and then we're going to type in basically our formula for class width. So again, that's the range divided by the number of classes. The range is the maximum minus the minimum. So here's how we're going to do that. Open a set of parentheses, and then open a second set. Remember, because the range is in the numerator of the class width formula. So in the numerator, I want to type maximum of what? Column A. A, colon A. The maximum of column A minus the minimum of column A. And then I want to close the first set of parentheses here. So we'll have equals round up, parenthesis, max, parenthesis A colon A, parenthesis, minus minimum, parenthesis A colon A, parenthesis. So the maximum minus the minimum is grouped together by our parenthesis symbols. That keeps the range in the numerator. I'm going to divide this, so I use the slash button, divide this by the value in C3. So you can either just type C3 or click C3. I want to divide the range by the number of classes, and I want to keep this as a whole number. So comma 0 means I want to round this up to the nearest whole value. And then we're going to close parentheses again. So our class width is found to be 13. If you did this by hand, the maximum was 105, the minimum was 15. So 105 minus 15, that's going to be our range. We would divide that by 7. It's approximately something like 12.8571, something like that, which would round up to 13. So our formula automatically does this by just referencing the column. Notice that we're not actually referencing the max and the min. I didn't type in 105 minus 15. I said, hey, find it. Find it in column A. Find the class number of class in C3. Use those values to calculate the class width. Notice how these cells will automatically update themselves if anything changes in the data set. For example, if instead of 30 being the first data point here, if I made that 130, it will automatically adjust the class width, right? Because now the max is not 105, it's 130, right? So it will adjust the range, it will adjust the class width. If I change the number of classes here, instead of 7, I put in 5. Again, it's going to change the class width because my numbers in the data set have changed. So I'll go back to the original values here, 30, and number of classes is 7. So the cool thing about Excel is once you have the formulas set up, any manipulation that you make in the data set is going to automatically update all of your formulas all at one time. You don't have to go through and manually change every single calculation that you want. Once the formulas are there, they will automatically update themselves. So that takes care of our class width for number 3. So I would put in 13 here for the class width. And now we're ready to create the frequency distribution. So this is something that you need to fill in by hand, either printing out the PDF and writing it yourself or editing it here in the Word document. You'll notice that I have kind of a makeshift frequency distribution here in the Excel workbook with 2 cells really for this first column that's in the Word document, right? The class is the lower and upper limits. So I have the class kind of separated into two different columns in the Excel workbook, one for the lower limit, one for the upper limit. Those two values together with a dash is what's going in this class column, lower dash upper. Then we've got the frequency and the midpoints, relative frequency, and cumulative frequency. So I will create it in Excel. Basically, you transfer this information into your Word document to create your frequency histogram. Okay. So we're going to start in E2. E2 for the lower class limits. And again, we want Excel to do all the heavy lifting for us. So we are doing this just with formulas and referencing cell values. So in cell E2, I'm going to type equals minimum, right? Because that's where our lower class limit of the first bin is going to start, is at the minimum of our data set. So we're going to type equals minimum of what? Parenthesis A colon A, close parenthesis. And then in cell E3, we just want to copy and paste essentially the class width added on to the previous class. So in cell E3, we're going to type equals whatever's in E2, right? So just go up and click E2 plus the value that is in C4, right? Every class limit from one lower class to the next lower class, they're going to be the same class width, the same size, so all the bins are equivalent. Now, in order to cement, I don't know if cement is a good word, in order to hold a value in Excel so that it doesn't change whenever you copy and paste, you use dollar signs. So I want to say that every lower class limit is going to add 13 to it. But I don't just want to type 13, because remember, I want Excel to update itself, so that if I change the data set, it automatically updates the class width and it automatically updates what I'm adding in the frequency distribution. So I just want to reference whatever is in cell C4. I do this using the dollar sign. We're going to say dollar sign C, dollar sign 4, and that's going to say use the value that's coming up in C4 and add it to all of these lower class limits. So when we hit enter, we go back up and click in E3, and then this little green square that it's in the lower right hand corner, I just want to click there on those black crosshairs and copy that formula down to E8, because that will give us the appropriate number of classes. So our lower class limit really should stop at 93. Okay, now we want to do something similar for the upper class limits. So we're going to start in F2, and we're going to say equals. Now, how does the upper class limit work? Well, it's going to stop exactly 1 unit before the next bin begins, right? So if the next class starts at 28, that means that the upper class limit of the first class should stop at 27. Now, do I really just want to write 27? No. If I change something in the data set, again, I want Excel to do the heavy lifting. I want it to update itself. So I'm going to reference E3 and just subtract 1 from it. E3 minus 1. Okay, so whatever comes up in the lower class of the next bin, I reference that in the end of the first bin. Hopefully we could follow that. Now, again, how do we go from one class limit to the next class limit? They should all have the same class width of 13. So in F3, we want to type F2 plus our reference class width that's in C4. So we're going to say equals F2 plus, again, we're going to hold the value that is the class width. I don't want it to change whenever I copy and paste. So $C, $4. And I want to copy and paste this formula down to the last row. So we should end essentially at the maximum, which is 105 for our data set. All right, now we are ready to fill in the midpoints. So I'm going to go up and click in G2. And G2 is, again, the average of the lower and the upper class, right? It's the physical middle of each bin. So what I want to do, in essence, I want to do 15 plus 27 and divide that by 2. But I don't just want to type that in because the lower and upper class limits might not always be 15 and 27. So instead, I just want to reference the values that are in that cell. So I'm going to type equals, open a set of parentheses, add the two values together, E2 plus F2. And we're going to close parentheses and divide that in half. And we should get our first midpoint at 21. Now, all of our midpoints should also be equidistant in terms of the class width. So the next midpoint should be exactly 13 units away. But instead of just saying G2 plus 13, I want to say G2 plus whatever is in cell C4. So in G3, my next midpoint here, I'm going to type equals G2 plus the value that is in C4 using my dollar signs again, $C, $4. Right. So we are going to copy and paste from G3. So highlight G3 again, click on that cell, hover over that little green box in the lower right-hand corner until it's a black crosshair. Copy that down. Our last midpoint should be 99. Alrighty, now I want to go through and actually tally up the number of data points that fall in each one of those classes. How many tickets are in the class from $15 to $27? How many tickets are in the class from $28 to $40? I don't want to go through 100 different parking tickets by hand. I want Excel to do this work for me. So here's the formula we're going to use in H2 to tally up the data values into their respective classes. We're going to do this by counting the value from column A if it is greater than or equal to the lower class limit and less than or equal to the upper class limit. So in essence, I'm telling Excel, count this data value in this class if it is greater than or equal to this, 15, or less than or equal to this, 27. Count it in that class if it falls in that range. So here's how we do that. Clicking in H2, we're going to type equals count ifs, COUNTIFS, count ifs, open a set of parentheses. Well, where am I counting? I'm counting in column A. So A:(A), counting in there. What am I counting? I am counting if something is greater than or equal to whatever is in E2. So after the comma, we're going to type what is this called? Quotation mark? Double quotation, like your dialogue or whatever. We're counting something if it is greater than or equal to. So quotation, greater than, equal to symbol, close quotation. And then we're going to use the ampersand. Well, what are we going to be greater than or equal to? We're going to be greater than or equal to the stuff in E2. So ampersand E2, comma, where does my counting end? Well, my counting is going to end still in column A. So we're going to say A:(A) again, comma. Now I want to end whenever I am less than or equal to my upper class limit. So open your quotation mark again, quote, less than or equal to, close quote, ampersand, the stuff in F2. So again, what this formula is saying is I want to count the data value in column A. So it's going to go down A1, A2, A3, A4, so on and so forth. It's going to go down that column and count the data values that are greater than or equal to whatever's in E2 and less than or equal to whatever is in F2. Now, here's how we're going to close this, just with a parenthesis, and we're going to hit enter. So there are 4 values in the entire data set, which is all in column A. There are only 4 values that are in the first class. If we go back up and click on that and copy and paste down our column, it counts all of the values that fall in each one of these bins. So there are 75 values between $28 and $48. Those are all the 30s that you see there. There are no values between 41 and 53. There are 17 values between 54 and 66. Only 1 value between $80 and $92, and 3 values in the 93 to 105 range. So those are the frequencies. Those are just counting up the number of data points that fall in each one of those bins. Okay, now we're ready for the relative frequency column. So in cell I2, we are going to create a, we're going to create a percent, essentially, right? Relative frequency means out of the total number of data points, what percentage of them fell in each one of these classes. So what we're really doing is creating an empirical probability, right? Count up the number of things in each class and divide it by the sum total, right? Which again, I know that I've got how many? I've got 100 parking tickets here. So I could just type equals whatever's in the H column divided by 100. But again, if I change the data set, that means I'm changing everything in the frequency distribution. I want it to automatically update itself. So again, I'm going to reference cells and I'm going to reference columns. So in cell I2, we're going to type equals H2, right, equals the frequency for that class, divided by what? The sum of everything in column H. The sum of everything in column H. Why do I want to sum the whole column? Why can't I just say divided by 100? Because again, if I change the data set and I change the number of classes, I could have 7 classes, I could have 8 classes, 10, 2, right? Depending on however many rows I need in my frequency distribution, I want to make sure I'm summing up the entire frequency column. So I want to take the value in H2 and divide it by the sum of column H. So SUM, open a set of parentheses, H colon H. Sum up everything in that column, that's numerical, right? And make that the denominator of our relative frequency. So 4%, and it makes it easy to know you're doing it correctly in this lab exercise because it is out of 100. So I should see 4% is in the first class, 75% is in the second class, 0% is in the third class, right? These values should make sense to us when we copy and paste them down because our data set is already out of 100, right? It's base 10. Okay, so those are our relative frequencies. Our last is to do our cumulative frequencies, sum up the cells as we go through the bins. So in cell J2, I want to type equals sum, open a set of parentheses. Now, what am I summing up? I'm summing up as I go, right? So to create cumulative frequencies, I want to reference the cell before, only the cell before, and add to it the current cell. So we're going to type sum of what? H2. Now, in between the H and the 2, I'm going to put a dollar sign so that the only thing that is holding fast is the previous cell number. So sum of H dollar sign 2, the previous cell, in quotations, previous cell, and we're going to do this through to the current cell, so H2. And then we are going to copy and paste this down. Now, obviously, you know you have done this correctly if the last cell is the cumulative total of your data set, right? The last cell should be your sample size. So we're going to maybe just click and check to see how this formula is working in, let's see, J3. What is this asking me to do? It's saying to take the previous cell, right, the previous amount, so H2's frequency was 4, add to it the next cell. Well, 4 plus 75 is going to be 79. If I move to the next one, it again references the previous column's value, to, the total, and adds to it the next frequency. Well, 79 plus 0 is still going to be 79. Then I move to the next one. Reference the previous value and add to it the current value. 79 plus 17 is going to give me 96, so on and so forth. So it's just summing up the values as I move through the bins. Okay, so these values, and again, E and F columns, these two together are what you're putting in the class column, right? The first one here would be 15 to 27. Our next bin is from 28 to 40, right? Together, columns E and F are composing the first set of values in the frequency distribution on the document. Okay, so fill that into your value here. Number 5 is also something that you can do in Excel if you're interested in learning how to graph on there. I can show you real quick how to create a histogram. What you want to do is click away from the frequency distribution. So I'm going to click somewhere down here below it, maybe E11 or something. Click away from the frequency distribution and then go up to your formula bar up here, the tab that says Insert. We're going to click that. And then we're going to click on the histogram icon. It's right in the middle here. It looks like a bar graph. We're going to click Histogram, create a histogram. So the rectangle that appears, it's going to be blank. It wants you to actually go in and select the data that's composing the histogram. So in the rectangle that appears, we're going to right click and we're going to select data right in the middle here, select data. So under legend entries, we are going to click add. And in series name, we're going to type frequency. Whoopsies, get my caps lock off here. Frequency. And in the series values, we're going to manually click and drag to select H2 through H8. So come up here to H2, click, drag down to H8 and let go. And then hit OK. Now we're not done. In the horizontal axis, we are going to click Edit. In the axis label range, we're going to manually select our midpoints here, right? We could use the lower and upper class limits, but in the middle of each bar, if I just use the midpoints, that's another great way to label our frequency distribution. So we're going to manually click in G2 down to G8 and hit OK. And we're going to hit OK. All right. Now, this doesn't really look like a correct frequency distribution. I would think that I would have 7 bars here, so this still needs a little bit of work. We're going to right-click the graph, and we're going to go down to Format Chart Area. Format Chart Area. Okay. And we're going to go to Series Options, so Chart Options, Series Options. And we're going to click on the number of bars that we want. We're going to change the gap width to 0. And then we want to separate the bars by category so that the midpoints actually become our horizontal labels here. So we're going to click back up in our down arrow and go to, let's find it here, Axis Options. Where's our axis? Horizontal axis. Axis Options. And we want this to be done not automatic but by category. So bins, make them by category, and that makes it look more like the histogram that we would expect, right? There's the midpoint of our first class, 21. We've got 4 things counted in that class. The next one, we've got 75 things counted in the class that has a midpoint of 34. So there we see all 7 classes. The ones that don't have any counts in them are 0. They are the gaps, right? So that's going to happen at 47 and 73. 47, 73. Another way to edit your graph is using these little quick access tools in the upper right hand corner. There's a plus sign. We can add axis titles and data labels, right? So that will put the frequencies above the bars. Let's see. Our axis titles, you can just click on them and edit them. And I'll zoom in a little bit. I can call the horizontal axis the ticket amount. And this is not American money, this is in Canadian dollars, so in Canadian money. Right, so I know that the horizontal axis, this 21 means $21, this 34 means $34, and then the heights of the bars are however many people or how many tickets fell in that midpoint range. Okay, my chart title, maybe I want to edit this to say exactly what my information is displaying. So this is parking ticket frequency data. Okay. And I can either copy and paste this graph or use my handy dandy snipping tool like I did in the first video to put this in my Word document. If, again, you would rather do this by hand and just sketch it out, you're more than welcome to do that and use the rectangular or coordinate plane that I already have uploaded in the Word document itself. Or you can copy and paste it and try practicing using the Excel histogram maker. Okay. Numbers 6, 7, and 8 are more calculator type exercises. In number 6, we want to use either the empirical rule or Chebyshev's theorem to understand maybe the percent of data that lies within so many standard deviations of the mean. Looking at the graph, right? So what was the purpose of really doing number 5 before number 6? The purpose of the graph is really to make us aware of whether or not the empirical rule can be used versus Chebyshev's theorem or vice versa. Remember that the empirical rule is only good for symmetric data. Looking at this distribution, I would be very hesitant to call this data set symmetric. It's pretty well skewed to the right. There are very few values in these upper line quadrants. So, you know, the empirical rule, hint, hint, is probably not the best thing to use. We want to try using Chebyshev's theorem in number 6. Number 7, you'll probably want to use the TI-84. We're going to use those estimated formulas whenever we just have the frequency distribution and we don't have the raw data set. How do they compare really to the true values of the sample mean and the sample standard deviation? So in number 7, you want to try using the graphing calculator. So what I would do would be to put my information from the frequency distribution into lists on the calculator. So what I would do is I would enter the midpoints into L1, and then I would enter the frequencies in L2. So maybe I will move my workbook over a little bit so I can see it as I enter in my values. So again, I would put the midpoints, the stuff in G2, I would put those in L1, and then I would put my frequencies, the stuff in column H, I would put that in L2. So remember how to work with lists. We're going to hit the Stat button, Edit. So in L1, I want to type 21, 34, 47, 60, 73, 86, and 99. So those are my midpoints. The frequencies I'm going to put in L2. So 4, 75, 0, 17, 0, 1, 3. So those are all my midpoints. Those are all my frequencies. These are the values that I use in the estimated mean, or what we call the weighted mean of a frequency distribution, and what we use for standard deviation. So to come up with those values, we are going to hit Stat, and we're going to scroll over to Calculate. We're going to use one variable stats. And now, again, I have an older calculator, so I have to manually type in which list I'm using and the frequencies for that list. So I'm going to use L1, second 1, comma, second L2. If you have a newer version of this calculator, you'll probably have a menu that says what list are you using and the frequency, right? So it'll say like list, colon, and you have to select L1. Then it'll say frequency, and you'll have to select list 2. If you have an older calculator, you have to type it in like this using the comma command. Okay. And it will pop out the estimated average and the estimated standard deviation just from the values on the frequency distribution. So remember, we're using midpoints here, not the raw data points. I literally assumed that the 4 values in my first class were all 21s. The 75 values in the second class were all 34. 0 were $47. 17 values were estimated at $60. These values that I'm coming up with using these estimated formulas are not using the raw data points. They're kind of averaged data points using the midpoint of the frequency distribution. So in number 7, I would write my average as $40.37, and I would write my sample standard deviation. Remember, S sub x means sample standard deviation, $15.40. So the mean, the average using the frequency distribution formula is a little bit higher than what we came up with in number 1. Remember, the true sample mean using every single data point in those 100 parking tickets was exactly $39.05. The estimated mean coming up from the frequency distribution is $40.37, which is pretty close. We're talking about a handful of dimes here as a difference between the true sample mean and the estimated sample mean. This sample standard deviation is a little bit lower, and this should be not surprising because we had a couple classes that have frequencies of 0, right? So those classes are going to lower our sample standard deviation, right, by kind of diminishing the values of those classes. So we would type in, again, $40.37 as the sample mean for estimated sample mean for number 7, and $15.40 for our estimated sample mean in number 7 as well. Okay. Last but not least, number 8 is just kind of an opinion question. We know how different shapes of distributions are going to affect our measures of center. So given that this is really kind of a right skewed distribution, do you think the mean, the arithmetic average, or the median, the physical middle, better represents a measure of center for this data set? So just kind of give me your opinion on that last one. If you have any questions about the Excel steps, don't hesitate to email me. If you would rather do all of this by hand and use the calculator, you're more than welcome to. I just like to give students a taste for how Excel can be super beneficial to us, right? Everything that we've got going on here in this spreadsheet is essentially coded, right? We didn't type in any of these physical values. We let Excel do that work for us. So any change in the data set is going to update our class width, and it's going to automatically update our frequency distribution. So this is really useful whenever you're working with lots of quantitative data and you've got to manage it all at once. Program Excel to do that heavy lifting for you, and you've got something that's up and running and working for any data set that you want. So again, let me know if you have questions. I will catch you in the next video. Thanks, guys.